Imagine, if you will, gazing up at the night sky, filled with countless stars. Now, picture one of those distant lights hosting a world with conditions that could support life. A new discovery by the James Webb Space Telescope has us wondering if we're about to answer the age-old question, are we alone in the universe? The potential biosignature that Webb has detected on the exoplanet K2-18B, specifically traces of dimethyl sulfide, a compound produced by organisms here on Earth, may be our first real clue that extraterrestrial life exists beyond our planet. But how did experts manage to detect something so small, so far away, on a planet light years from Earth? And, if there is alien life out there, why haven't we seen any signs yet? This brings us to the famous Fermi paradox, a question first proposed by physicist Enrico Fermi in 1950 that asks, if extraterrestrial civilizations do exist, why haven't they reached out to us or made themselves known? In today's video, we'll break down how the Webb telescope managed to uncover potential biomarkers in K2-18b's atmosphere. We'll explore the tantalizing possibility of alien life and dive into why, if other civilizations do exist, they might be hidden from us. Let's journey to the edge of discovery together. For centuries, humanity has gazed at the stars and pondered the existence of otherworldly beings. We've searched for signals, analyzed cosmic radio waves, and even sent spacecraft like the Voyager probes, carrying golden records with music and messages meant for any intelligent life that might come across them. So far, we found nothing conclusive. But the discovery of exoplanets, planets outside our solar system, has opened new doors. The James Webb Space Telescope is our most advanced tool yet for peering into the universe. Launched with the ability to detect infrared light, it can see objects that are tens of billions of light-years away. It's also capable of analyzing the composition of atmospheres on distant exoplanets, a game-changer in our quest to find signs of life. With Webb, we can finally study planets like K2-18b in greater detail than ever before. K2-18b, the exoplanet at the center of this recent discovery, orbits a cool red dwarf star in the constellation Leo, about 125 light-years from Earth. This planet lies in what astronomers call the habitable zone of its star, meaning it's at just the right distance where liquid water could exist on its surface, one of the fundamental requirements for life as we know it. The tantalizing discovery Webb made involves a compound known as dimethyl sulfide, DMS. On Earth, DMS is mostly produced by phytoplankton in the oceans. Because this molecule is linked to biological activity, scientists refer to it as a biosignature, a sign that life could potentially be present. Along with DMS, Webb also detected methane and carbon dioxide in K2-18b's atmosphere, both of which are often found alongside biological processes. But let's pause for a moment. How did Webb manage to capture this data? It's mind-boggling that a telescope can study the atmosphere of a planet located trillions of kilometers away. Webb's trick is to look at starlight passing through an exoplanet's atmosphere as it transits in front of its star. When light passes through, molecules in the atmosphere absorb specific wavelengths, creating what we call spectral lines. By studying these lines, scientists can determine which gases are present. If DMS and these other compounds truly exist in K2-18b's atmosphere, they could signal that we're not alone. But why aren't scientists jumping to conclusions? The short answer is that while these findings are exciting, they're not yet definitive. The DMS signal detected on K2-18b was faint, meaning it could still be a false positive. The Webb team plans to use another of the telescope's instruments, the MIRI, mid-infrared instrument, to further analyze this distant world. The team will also use atmospheric models to understand the possible sources of DMS in more depth. If these models confirm the presence of DMS, methane, and carbon dioxide in a way that aligns with biological processes, then this could be the closest we've ever come to discovering extraterrestrial life. Even with today's powerful telescopes, finding absolute proof of alien life remains incredibly difficult. If extraterrestrial beings exist, why don't they just reach out to us? The Fermi paradox raises exactly this question. The idea behind it is simple: the universe is vast and has existed for billions of years. With so much time and so many stars with potential habitable planets, we would expect intelligent civilizations to have emerged and possibly developed advanced technology. They could have reached out to us by now, or even visited Earth. So, where is everyone? One explanation is that the distances are simply too vast. Even if another civilization wanted to communicate, the travel and transmission times would be impractical. Our nearest star system, Alpha Centauri, is 4.37 light-years away. For context, a light-year is almost 10 trillion kilometers. Even at the speed of light, it would take over 4 years just to send a one-way message. Other theories suggest that advanced civilizations might deliberately choose to stay hidden, abiding by a galactic quarantine until humanity is advanced enough to interact. Alternatively, it's possible that intelligent life is very rare, or that advanced civilizations have already collapsed. With its potential oceanic environment and biosignatures, K2-18B represents one of the best chances we've ever had to find extraterrestrial life. Scientists believe it may be an example of a Hycean planet, a type of exoplanet with a hydrogen-rich atmosphere and vast oceans. This is significant because Hycean planets were theorized only recently, and if they exist in abundance, they could vastly expand our search for life. Unlike Earth-like planets, which need specific conditions to support life, Hycean worlds might support life under a wider range of conditions. Their thick atmospheres could help maintain stable temperatures, even if they orbit close to their host stars. For K2-18B, this means the potential for an environment where water is in a permanently liquid form. So why does this matter? Water is critical because it dissolves nutrients and facilitates chemical reactions necessary for life. If K2-18B truly has vast oceans, then it might also have the right conditions to support microbial life, even under a thick hydrogen atmosphere. For now, Webb's observations of K2-18B's atmosphere are promising but not yet conclusive. Future observations and more detailed modeling could help confirm these findings. Meanwhile, scientists are already working on the next generation of telescopes that will be even more powerful than Webb. The upcoming telescopes, such as the Nancy Grace Roman Space Telescope and the European Extremely Large Telescope, EELT, will likely provide more comprehensive data on distant exoplanets. They'll be able to analyze atmospheric components with even greater accuracy, helping us to confirm or refute the presence of life-sustaining compounds like DMs. And in the next few years, we might even be able to detect signs of more complex life, such as plants, animals, or even intelligent beings. Imagine finding evidence of another civilization's technology, what scientists call technosignatures. These could include radio signals, pollution in an exoplanet's atmosphere, or even the light from massive cities on distant worlds. As we stand on the edge of one of the most profound discoveries in human history, we must also consider the responsibility that comes with it. Are we prepared for the implications of discovering extraterrestrial life? How will it reshape our understanding of our place in the cosmos? For now, we can only speculate, but one thing is certain: the search for life beyond Earth has entered a new era. The findings from K2-18B have brought us one step closer to answering the question that has fascinated humanity for millennia. So, what do you think? Are we alone in the universe? Let us know your thoughts in the comments, and if you found this video as intriguing as we did, make sure to give us a thumbs up and subscribe for more updates on the latest discoveries from the James Webb Space Telescope and beyond. Keep looking to the stars, because who knows what will